I'm talking about today is Unity topics for artists and programmers. We did one yesterday for just the coders. This one just applies to everybody. Everybody who uses Unity probably should be doing these things that I'll be talking about. I've learned a lot of this stuff from computer science. I've learned some of it doing stuff on the job for companies working with Unity and running into problems myself, sometimes for months before I figured this stuff out. So most of it's pretty simple to do, and I'll talk about why they're problems and then what you can do to fix them. So that's basically what all this is about. So we're going to talk about prefabs. They're probably the single most important thing that you should know about for performance reasons, for just keeping everything organized. They're an organizational structure for you to use. We're going to talk about naming conventions of all things in Unity. We're going to talk about file organization briefly. And then we're going to have a big section about graphics optimization and just stuff to just generally keep in mind when you're doing anything visual or importing things or using textures or anything like that kind of stuff. So we're going to talk about shaders and materials. We're going to talk about verts. We're going to talk about using textures in base 2. That's a big one. And we're going to talk about lights and the static flag. So all this is cool stuff. All this stuff won't really change how things look. It'll just make it easier for you to hit a frame rate, is basically what all that graphics optimization stuff is all about. So let's just get right into it. Prefabs. I have talked to Nathan about getting everybody to use prefabs. I think they're one of the most important things you can do in Unity. I've made the mistake of not using them, and it is a horrible, horrible mess, and you basically just spend all your time replacing everything with prefabs. But they just make everything in your life simple. They're basically, prefabs are reusable asset templates. So anything you put in a scene, whether that be like a model with a texture on it, or maybe you make a clock with a script on it, all that stuff can be turned into prefabs and stored in the asset files of your Unity project so that they can be instantiated infinitely and they're all identical. Or if you want, you can just put a whole bunch of prefabs in a scene, and every time you change the prefab, it'll update all the ones in all your scenes automatically. So you should use prefabs for everything in your scenes. Basically, a period after that sentence. There's basically no reason not to do it. It's just because if you're making something like, let's say, a lamp, and it's a model of a lamp, and it's got a light in it, and might have a script in it, you might want to change the size. You shouldn't ever be modifying it in the scene, ever. You should make a prefab of a lamp, build it, then place it in your scene, and then only edit the prefab. And that's how you should do everything in Unity. That's just good practice, because if you take the example of the lamp, if you want to place 100 lamps, if you've changed things, or you've changed the intensity of the lights, or you've changed the positions of things, or the UVs on your textures or something, in the scene, it'll only exist in that one scene, and you'll have to copy and paste it 100 times over. That's a ludicrous amount of work, and it is simply you just go right around it by just making prefabs and just using prefabs religiously. You should be doing everything you do everything should be done in prefabs. The only thing that you should not use prefabs for are folder game objects. So if you want to make a structure in your scene, like you want to have all your lights under the same game object so you can move them around all at once, that's the only exception to that rule. Everything that you put in a scene should be a prefab. That's the long and short of that. So what are the reasons why is this such a big deal? For one, the main reason is that you can modify, like I've said, you can modify and replicate assets without needing to change the scene file. So issues that we're running into at CogPro and at Edmonton, and I've run into this in the past too at past companies, multiple companies, and on game projects in school and all sorts of stuff. It always comes back to an issue. It's just really, really simple to just use prefabs, but you don't need to change the scene file. So you put a prefab, if you put that lamp into the scene, if I am working on the light prefab, it doesn't modify the scene. I could add anything I want to that prefab because the scene file just says, basically, it's just a bunch of markup text that says, there is a lamp at this location. And it doesn't have any details about what the lamp is. It's a prefab, so it just refers to the prefab. So you can put anything you want and do anything you want to the prefab, and it doesn't change the scene file at all. So how you, the workflow of prefabs should be, or of just scenes in general, is you should make a scene, everyone should have the scene, you place prefabs in the scene, so when you place prefabs in the scene, it modifies the scene file, obviously. But if you're working on parts of the scene, they should be prefabs, and you should be changing the prefabs. And that just avoids the whole issue of people, multiple people working on the same scene file at the same time if it's not necessary. Because basically the only time that the scene file should be modified is if people are adding things or removing things from the scene. That's the only time. So it just removes all the work from editing the scene file, and you just work on the specific assets themselves. It's really clean. Everything just works out if you use prefabs. You can also duplicate with ease. Like I said, if you have a lamp, you can duplicate 100 of them and then modify them all at once, and the prefab system keeps track of all the changes and updates them all automatically. So I'm going to show you a quick example of how to actually physically do this stuff, because maybe you're a bit confused about what a prefab looks like. It's pretty simple. I've got a little scene here. This is a game I'm working on with my brother. It's very inefficient, so it's a really great place to see some really inefficient things. So in this scene, I've got a little table here, and it is not a prefab. It is just a mesh that somebody just dragged into this scene, and it's just existing here. So if I change the scale of this, here, if I want it to be a little bit longer, I can drag this value, and it stretches it. But this only exists for this one table in this one scene. So if I have a different scene and I want all the tables to be the same, you would always just make a prefab. And even if you wanted to have a table that's longer and one that's shorter, you should make two separate prefabs. So what you do to make a prefab of this, if it's already in the scene, is you just simply drag it, whoops, click on it. Oh, my computer's so slow. Let's do this. Desk. Drag it into the inspector. So I've got a little file structure in here. It's pretty disorganized, but you can just make an original prefab, and that's it. It's prefab. So every time I modify this prefab, ignore this desk. This is the prefab. So it says desk.prefab. I can double click on that, and I can make all my modifications to this prefab. So I'm gonna stretch it, and then go back to the scene. Look at that, it's stretched now. And it's as simple as that. That's how everything you do in Unity should be done. Everything. So if you're modifying the environment, if you're modifying walls, if you're changing enemies, every single thing you do should be done not in the scene. Right here, if I stretch it in here, this is inside a scene. So if I stretch it here, it's stretching it in the scene, and then it's breaking the prefab instance, because basically you're making another example. You shouldn't be changing things in the scene. If you want to make this table longer, you should be going into the prefab and changing it here. That's basically the long and short of it. There's lots of cool stuff you can do with prefabs. You can have prefabs within prefabs. So if it's a really complicated thing, like let's say this desk has computers on it and it's got UIs and all this crazy stuff, you can have a prefab for the UI on the computer. You can have separate prefabs for all the parts to it, and everybody can work on the separate individual sub-prefabs at the same time, and they won't affect each other because they're all separate entities. And then you can use use Unity Collab and all that kind of stuff, and they're not colliding with each other. They're not modifying the same pieces of code. They're totally separate parts of the project. So it's really important from an organizational standpoint that you do this kind of stuff. It just makes it easier for everybody, and it makes everything really consistent in your scenes, and also your scene files are smaller, because if you're modifying all these values individually in every single part of your scene, it's just adding more stuff to the scene files, and scene files can get enormous. But if you just use prefabs, there is no data stored in the scene file for specific values of your scale and rotation and all this stuff. If you're modifying any of these values in the scene, it's just going to make your scene file big, which is kind of pointless when you can just use prefabs. And something else you should do with prefabs. So let's say if I want a table, I want a desk, and you know what? Actually, I want two desks. I want a long desk and a short desk. You don't copy it. You can copy it, but don't copy it and then change it in the scene. We've kind of established that. What you should do is you should make a second one. Make a second prefab. So this is called desk 1. I'm just going to call it long desk. Perfect. So now I'm going to modify long desk, and it's going to be even longer. And so every single time you want to make a special, a specialist of something, let's say you have an enemy, for example, in a Unity game you're building. You don't have enemy and then you change all the values in the scenes. That's just bad practice. What you should do is you should have a different prefab for every specialized type of game object that you want to have. So that's how everything should be done. It's pretty simple, but I mean, the thing with Unity is that Unity will let you get away with anything, so you can do everything in the scene. It's just not good practice, and it's just it makes it harder if you're working on a bigger team. I find it's not a big deal if you're working with one person, but you start adding people to the team, and this stuff gets really complicated and really messy. So this is just a nice way to organize everything you're doing and keep it all clean. Apologize, my computer is really slow. All right, let's talk about some naming convention stuff. Pretty simple stuff, but just a couple things to keep in mind. It makes everybody's code a little bit cleaner, a little bit nicer. This is the naming convention I've seen for all C# Unity projects, even VB.NET projects at other companies. This is always the naming conventions they use for objects and all this kind of stuff. So I have always, at every company, had to use Pascal case for objects, classes, and assets and functions. So that's a pretty big one. I've never seen any deviation from that. So what I mean by Pascal case is the first capital letter of the first word and all the subsequent words, the first letter is capitalized. So in this case, Pascal case would be public void, which is a function, big bird motion controller with the two B's, the M, and the C capitalized. That's Pascal case. And all objects, all classes, all assets, and all functions should follow that naming convention. And then the only exception for that is camel case for variables. So anything inside, like a class or something like that, like in this case, I have round counter. The first letter of the first word is not capitalized, and the second one is. Just so you can see at a glance if something is a variable, or a class, or an object, or a function, or something like that. So basically, those are the two types of cases you use for basically everything, and it keeps it really nice and consistent. Like that's this Pascal camel case thing is not arbitrary. This is like Microsoft's naming convention for their variables and their all that kind of stuff. And if you deviate from it, you physically can do it. It's just not convention, and everyone likes to be consistent. The second thing I want to say about naming things is just call a spade and make it descriptive. And when I say call a spade, I mean describe things. Like name things as a description. Like somebody should be able to see your name and have a pretty good idea of what it is. If your names are vague or abstract, it's probably a bad name. So just give it a descriptive name, and don't be afraid to use a couple of words. Like in this case, you could call all your bird prefabs bird 0, bird 1, and bird 2, but that's not very descriptive. It would be descriptive to call them eagle, sparrow, and flamingo. Those are descriptive words to describe these things. Pretty simple stuff, but I just thought I'd point that out. It's good practice. Don't use hyphens or spaces or underscores in the names of anything, basically without exception. So in this case, a function doesn't have any underscores. That's good. This green monster.asset, that's good. Putting underscores in function names, I have never seen that done. Or dashes in the name of assets, you really shouldn't do it. It just makes everything look a bit lopsided. Avoid abbreviations at all costs. They're really confusing, and they don't. Like, names should clarify, not confuse. So if your names are abbreviated, you should probably just try and avoid that unless it's absolutely necessary. Like in this case, I've got darkvampire.asset. You shouldn't shorten it to dvamp. That's not descriptive, and someone who doesn't know that there's a dark vampire in this game or program probably won't know what a dvamp is, as an example. So something to keep in mind. More conventions. Keep the most specific descriptor to the left. This is it's not a hard and fast rule, but like it makes it more sense to call something pausebutton.asset instead of buttonpause.asset. Put the most specific descriptor, which would be pause in this case, to the left. So you can have pause button, stop button, start button, instead of button stop, button pause, etc. It kind of makes intuitive sense, but just something to think about when you're naming things. One exception to the underscore rule are aspects of the same asset. So you might see things like darkvampire.texture, and if it's a different aspect of the same asset, like let's say there's a normal map and a diffuse map, you can separate them with an underscore. That's fine. That doesn't break naming conventions. Something you can also do is if you have different states for pause buttons. So I've got a pause button state. I've got two of them. I've got an active state and an inactive state, but it's the same button. It's just a different aspect of it. That's maybe an appropriate way to use underscores to like differentiate things when you're naming things. I'm going to briefly talk about folder organization. There is no silver bullet. It really depends on the project, and just I guess kind of use common sense. But here's a really good example of a way to structure your folders for things to make sense and be easy to access everything. Try not to use too deep of a file structure. I find it really annoying to have to go like 5 or 6 or 7 or more levels deep to find what I'm looking for. I kind of build more breadth wise and have folders for things that I'd want to access quickly. So in this example, I've got third-party things, I've got animations, I've got sound effects separated into 2 categories, I've got materials and models into separate folders, a plugin folder, a folder specific for prefabs, with subfolders for every individual prefab, a resources folder, which is a really special type of folder that does something very specific in Unity, and I don't recommend you ever use it. It basically means everything inside of it is committed to RAM as soon as the Unity engine starts. Try not to use that. You basically, unless you know exactly what you're doing, should never use it. I have used it once, and it's a bad idea. A texture folder, a debug specific folder for building things that just help you test things and all that kind of stuff. Scene folders separated into levels and other. Kalesh said it's paused on his. Swap your application to resume. What does that mean? I'm streaming my screen. Yeah, it doesn't want. Let me try it again. Let me try it one more time here. I just hard crashed. Amazing. Well, we got the one hard crash out of the way. Yeah, go for it. Uh-huh. Mhm. 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 Yeah, that's a good question. When I in this example here, I was thinking more in the if you're making prefabs, like let's say you have a bunch of birds, like you could have a bird 0, bird 1, and bird 2. But if each one of those birds, one's an eagle, one's a sparrow, one's a flamingo, you should call them that. But in a scene, like let's say you have the same chair like 15 times in a classroom, perfectly fine to go chair 0, chair 1, chair 2 in the scene hierarchy, if that kind of makes sense. Yeah. Hmm. Oh, okay. Um, Use your best judgment, but from my experience, the only time you'd ever use underscores for any part of any asset, and what I mean by asset is anything in Unity that's in this area here, So, like, for example, I've got all these materials and things like that. This is a bad name because it's called new with a space material. This really should be something like new material. That's a terrible name as well, but you get the idea. But you shouldn't use an underscore in between new and material. That does break the Unity convention. That is not in convention. You can say new material and then specify if this is like let's say this is a diffuse map or something like that. For example, you can go diffuse because it's saying new material and this is the diffuse map, and then you can have new material and this is the normal map. That's an okay way to use underscores, but as far as I've ever seen, no one in Unity uses underscores for any other reason. If that makes sense. Private members. Yeah. Okay. There is a couple of exceptions to these rules. You can also. I mean, this is not really in the scope of this. I try not to get too complicated, but what you also can do is some people actually, in like the highest level of your hierarchy, if you want, like if you have a whole bunch of folders, which you probably shouldn't, I've seen people put underscores in front of them to push them to the top of the stack here, because an underscore just comes first in the library. So if you want certain folders to come first in your folder hierarchy, if you put an underscore in front, it can push it to the end. I wouldn't recommend doing that because there's other ways you can get around having things go to the top, and that's gonna take a million years to get these textures because they gotta move them all. Um, but yeah, private members in functions I think is another one. That's probably all right. Um, I think folder organization is pretty self-explanatory. Just try to separate things into think of a breadth, like a wide breadth, like of a script folder, a scene folder, textures and prefabs and models and materials should all be in separate folders, and then just make subfolders. But really, this does differ for each project a lot. Like some projects don't have a lot of these things, so you can just cut out folders. So, but this is just a good place to start, and then change it based on your needs. Um, but a lot of what I want to talk about today is just optimizing graphics because it takes a lot of knowledge. I'm sure some of you have some of this knowledge, but I think it's good to just go over it because graphics optimization is a huge part of what I've done in the past, and I've run into a lot of problems, and a lot of them are really simple to solve. You just got to know a couple of things and just keep your eye on some things, and they're really not that difficult to solve. So if you don't know, materials are like an instance of a shader with variables like textures and other types of variables that determine how things look. So this little rock-looking thing has a material on it that's got a bunch of maps on it that make it look bumpy and make it look rough and make it look like rock, and it's got colors and all that stuff. Materials is what controls all that. So when we talk about in terms of graphics optimization, really the question is always what can I get away with? According to technical artists. I'm not a technical artist or a graphic programmer, but I know a couple of things about optimizing graphics that you guys might find helpful. So just think about that whenever you're doing stuff with graphics or anything visual, is what can you get away with? What can you cut out and have it still look the same is another way to say that. And these are a bunch of ways that you can do that. So very simply, shaders are GPU programs that tell materials how to behave. Shaders work exclusively on the graphics card. And graphics cards are optimized for these kinds of tasks. So the types of things that go into graphics cards are what they're specially made to do. A graphics card is kind of like a specialized CPU that has really specialized circuitry for doing certain types of tasks, like things with vectors and shaders, really, really quickly, like way faster than a CPU. It's a specialized CPU type. A material in Unity, in the Unity's context, is like an instance of a shader. So a shader is a program that says, put these pixels here in this way, and a material is like an instance. It's like you can assign a texture to a shader, and that's a material. So it'll contain textures, it'll contain variables. Like if things are shiny and you want to change how shiny it is, that's a variable that you would have inside a material that the shader would use to determine how something looks. You can also have things like logic gates to switch off to different parts of the shader. And that kind of gives you the general shader. Like you'll see in Unity, I'll show you exactly what they look like. If you just drag and drop a wall into Unity, you'll see it's got a shader already attached to it, and it's always the standard shader. And if you pop it open, the standard shader has a lot of stuff in it. There's all these things in it. It's got a rendering mode. It's got all these types of maps that you can choose to put in there. It's got metallic slider. It's got a smoothness slider. It's got emission. It's got all this stuff in here. So that adds complexity. The good thing about this is that you can do anything with it. Like, I can add all these maps and I can change all these things. But the downside is if it's just a wall that doesn't look that special, that's a lot of performance to kind of waste on something that's not really being used, because this all passes at the GPU, and every time you add more complexity to shaders and to materials, it adds more milliseconds onto the time that it takes to render it, basically. So when you're thinking about getting into the portion of your project where you want to focus on graphics optimization, you want to think about what you can get away with. So I'm going to talk about what you can do to get around this kind of stuff. So big companies, like games companies and all that kind of stuff, they don't use stock shaders. They may at the beginning to test things, but they build their own really quickly to be as efficient as possible while achieving the same results. They just do exactly what they're supposed to do and nothing more. They don't have all these options that you can turn on and off. They have special shaders built for every application. And the person who does that is called a technical artist or a graphics programmer. And again, I am neither. So what can you do about all this stuff? So this is all an issue. It causes problems. It causes performance issues. What can you do about it? Well, something you can do about it is you can write your own shaders in ShaderLab. ShaderLab is a programming language that we talked about yesterday. It's a bit complicated. It's got like programming syntax, and you do have to have a pretty good understanding of how a graphics card works to be able to use it effectively. But there's also programs like this one previously here. This is like a visual one. This is actually something you can do in Unity. You can download this package. I think it's called Shader Graph, and you can build your own shaders visually. And this is how Unreal Engine does it. I've done all my shader programming visually. Basically, you just have maps, and you just put textures in there, and you just drag lines onto other dots, and they just make the programs for you. What you can also do, which is even easier, is just use less expensive shaders. Like, for example, in that little drop down, you can change the shader type to mobile, and you can use mobile shaders. Mobile shaders have a lot less options. They look a lot not as good. Like, they just look plainer. But like for things like simple walls that just have shadows and they just react to light, it's really not that it doesn't look any different. And if you can get away with it, if you can just play around with these shaders, you can get a pretty significant performance gain without having anything look any different. And that's kind of the goal of a really good graphics programmer, is to have everything look exactly the same, but to be twice as performant. So again, ask yourself, what can you get away with without seriously compromising quality, obviously. So what else can you do? So this is a bit more in-depth, but you can use the same material if it's possible. And this might sound a bit complicated, but if many objects can use the same material, like let's say it's our little example from before, so it's just a regular wall, it doesn't have anything special to it, it's got a certain smoothness, and you have a bunch of different walls, but let's say they have different textures, you can use something called a texture atlas, and you can batch them together, and that really seriously, incredibly changes the performance. So they basically, texture atlases, this is an example of a texture atlas. This is basically, instead of having, this little bag thing, I don't know what the hell this is, but having this as a texture and having every eyeball as a separate texture and this explosion as a separate texture, all separate PNGs or JPEGs, and having them all separately, basically every time you call a separate texture like that, it's a different draw call. So if you batch them together into one texture, the CPU can say, hey, have this giant texture atlas, and then just here's some new UVs to say, like UV is basically how the graphics card determines where the texture is. So a UV is like, say, start from this point and go to this point. This is the UV for this little tube thing here. And so it only has to send all this data once instead of once for every single picture, and it makes it way more efficient. It reduces your draw calls, and that's a really big performance hit. If you're sloppy with how you do your textures and your batching, you will get a lot of draw calls, and it will really seriously affect your performance. And I've run into this problems a lot. And at some companies where we have time to do performance improvements, we sometimes spend like a month or more doing just stuff like baking things into texture atlases and these types of things. They take a little bit of time, but they really seriously do make a huge difference to performance. Yes. So, and if multiple assets use the same texture and material, batching increases performance even more. So awesome gains. So that is definitely something to look into. Um, so doing this kind of stuff is called texture packing. So this is another example of a texture packed thing of some fire. I have in the past used a program called Texture Packer. I don't have time to explain how to use it, but it's a semi-free program that will take a bunch of pictures and pack them in a texture for you really efficiently, and it makes all the UVs for you for specific platforms. Like it's got a Unity setting, it's got an Unreal Engine setting, and it'll make the UVs for you. So you can just have a huge texture with 100 different textures in there, and you can just put them in there all at once, and you have a whole bunch of textures ready to go. And importantly, it puts them into a power of 2 texture, which we'll talk about in a minute. You can also make texture atlases manually, but it's a lot harder. But these are things that do make a big increase in performance if you want to go the extra mile. Something else that is an issue sometimes is losing track of your verts. Verts is short for vertices, I think. I'm not a graphics guy, but basically it's how many triangles does a model have, because a 3D model it's basically a bunch of triangles, no matter what it is. It's a bunch of points that connect into triangles, and when you send a material to the graphics processor, you're saying, here's how to shade in the spaces on these triangles, basically, is what you're saying. So complex models have a lot of vertices, and simple models don't. It's pretty simple. But loosely, very roughly, and this really depends on your hardware you're building for. If it's mobile, it might be even less, it might be more. But around 500,000 to a million verts in a scene is quite a lot. That's like, if you're getting into those types of territories, it's probably time to take a look at optimizing some of your models. And so you can check this stuff in Unity. It'll count how many verts are rendering, how many verts are in the scene, and all that kind of stuff. But basically, you want to ask yourself: are they in the right places? Like, if this item has 100,000 or more verts, does it actually look like something with 100,000 verts, or is it just poorly built? Not poorly, but maybe just unoptimized. Like maybe you got something off the internet and has a ridiculous amount of verts, and it just needs simplifying down to something a little bit cleaner. And ask the question: can you half the verts, and will it look the same? You can use something called an LOD system, which is like an automated system that lowers the number of vertices on your models. I again don't have time to talk about that, but these are all things you can think about to improve your performance. So if a simple object like a lamppost has 15,000 verts, it's probably a red flag. So just like keep an eye on how many vertices your models have, and it will really help the performance of your games, especially VR games, because they are really sensitive to having too many verts. And I've spent a lot of time going back and forth with artists at previous companies, trying to squeak every vert away from the models they send us. Like, does this need to have 15,000? Can it be simplified a little bit more? That's the kind of conversations I sometimes have. Basically, a lot of vertices taxes the CPU, because when they pass the information to the GPU for crunching all the numbers and doing all that fun stuff with the shaders, it takes time. So every extra vert takes a little bit of time. So anything you can simplify just helps everything, makes it more performant. Something that's important: all your textures should be power of 2. And what I mean by that, I actually didn't put an example here, but I mean like 2, 4, 8, 32, 64, 128. So these are all dimensions of your textures. So you can have a texture that's 1024 by 1024. That's power of 2 texture. You can have things that are, like, let's say, not a perfect square. They don't have to be perfect powers of 2. They could be, for example, 1024 by 512, so like a rectangle. But basically, the long and short of it is GPUs cannot work with textures that aren't power of 2. So it's either you do it or Unity does it for you. Unity has a system to do it automatically, but basically what you get is you get artifacts and stretching, and it also uses more memory. It also takes more time to build. So it's a really good thing to think about using power of 2 for all textures on all things, sprites and all that kind of stuff. A MIP map requires powers of 2. So MIP maps, very simply, are textures that create smaller versions of themselves when they're far away. So there's usually a MIP map system in Unity and Unreal Engine that says, If you're between this distance and this distance, use a lower resolution texture. But the mipmap system requires power of 2 textures to work. That's just how they work. If you don't put power of 2 textures, they just won't work. And it greatly, incredibly increases performance, because if you're honest, if you have a guy's eyeball or something like that, it might look awesome close up, but it doesn't need to be a massive texture from 100 feet away. It can be automatically toned down with a mipmap system, and all that it requires to do that is a power of 2 on the texture. That's all it needs. So it's pretty simple, but just something to keep in mind. So the takeaway here is, if the size of your textures are arbitrary, always use power of 2. And as a side note to just textures, while we're on the topic, watch out for texture sizes. Just be aware of them. Like, doesn't an extra's hand texture need to be 4K? Can they be 128 by 128? And I know, like, you guys, like no one I've ever worked with is stupid. They know that stuff, but sometimes it's just something that people overlook. Like, people are used to making really high definition textures, and when you put a 4K, hand texture in something, like, that's a really hard hit to the performance. So it's stuff that I have in the past, other companies taken back to the artists and be like, this is a little too complicated. Can you give me a little bit simpler texture? Just crunch it down for me. And it's really as simple as that, and it makes a huge impact on the performance. So in this case, you could probably change it to 128 by 128. If there's nothing really complicated going on, you can get away with stuff like that, and always come back to what can you get away with, and still have it look the same. And also this little option here, like let's say lowering from 4K to 128 by 128, that can be done right in Unity in the texture options. So you can actually have there's like an import setting. I'll just show you actually. Textures. What's the weird hand thing? Ooh, disgusting. So you can say max size. See, this is a 1024 by 1024. It already defaults to this, but if you want to make it smaller, like let's say that's a bit too detailed for my game, let's make it 128 by 128. And this will enforce the maximum size, so it doesn't use anything larger than that. That's another way to do it. And then when it builds, it'll only build this 128 by 128 version. So that's a cool way to do it if you don't want to actually remake all your assets. There's some shorthands you can do in Unity. Cool stuff to keep in mind. Because sometimes, eventually, you're going to have to worry about performance. Okay, I'm going to talk about lights, because lights are one of the most expensive things that you can do in Unity, and they can get out of hand really quickly. You should always, basically as a rule of thumb, always use lights statically. So if you have a light, you can click on it, and it'll have like a little flag. All game objects have this flag, and you can check mark static. Basically, unless you're physically moving the lights around a scene, like I don't know, it's a car with the headlights, that's a non-static light. But if it's just like a light that's lighting a room up, it should always have the static field. Always. It makes a huge performance increase to have all your lights as static. So unless you plan on moving your lights, make them static. Simple change makes a huge difference. Lights that are non-static require much more processing power because they have to account for moving dynamically. And there's also, I'm not sure in Unity, but I know in Unreal Engine, there's definitely a really hard limit to the number of dynamic lights you can have in a scene. I think it's like 8. Like if you need more than 8 dynamic lights, you actually have to do some fancy stuff and make some lights static and then make other lights non-static. I'm not sure how you do it, but yeah, the engines intentionally limit that to stop you from making too many dynamic lights. They'll just automatically make static lights for you after a certain point. Also, as a side note, just use less lights. Try to illuminate rooms with 1 light. And while we're on the subject, you should always make unmoving objects static. So if you know something like a wall or a toilet or something like that, something that's never supposed to move, you should always use this static flag. Unless something's going to move, like a person moves, the player moves. But anything that's like walls or objects on the ground, you should always make them static, because Unity, when they pass the geometry to render to the GPU, anything that's got this static flag checked will be batched together, so you can reduce draw calls pretty substantially. You can make some pretty impressive performance increases just by doing this one simple thing. You just go through all your things, and if they're never going to move, make them static. It's really simple, and it really makes a huge impact. So just something to keep in mind when you're making scenes. Here's an example. This is Oski's light system. It's got 12 lights in this room. That's fine. It looks cool. And in if you're doing like a hardcore rendering thing, it's fine. But if you're doing VR, that's pretty expensive, um, because they basically all illuminate the same area from the same direction. So you probably could make this with one static directional light. So what I've done as an example is just remove the lights and then just have one directional light. So it's providing the same light from the room's perspective. It's not going to make a difference in the way the room looks really, because it's way up here and nothing's blocking it. It'll illuminate the whole room correctly. But but it's just way more efficient. It just makes things run so much better. So what I've done in the past is I've gone a little gung ho with the lights, and I want lights here and lights here, and then we come back to the performance stage, and the lights are hitting it so hard that we have to like remove some, and so you just have to get a little clever about where you put lights and how you place them. To make the illusion that there's more lights in the room than there actually is. There's lots of the things you can do. You can use emission maps on textures to make it look like there's lights on the wall when there isn't. You can use static lights that bake lights, so then you just pre-process all the lighting effects, and that gets that. I mean, it looks almost the same for all intents and purposes, and it's way more performance, I should say. So cool little chip. Hardly takes any work, and it makes a huge impact.